Hello everyone, Mr. John here from Areteem Institute and ZIML. Today I'm going to be going over a problem from the 2020 AMC 10 and 12B exam series. This problem appears on both the 10B and 12B exams as number 25 on 10B and number 24 on the 12B. Let's look at the problem right off the bat. So problem here is about d of n, which is the number of ways to write a positive integer n as a product of different factors. So we have a bunch of things bigger than 1, right? The order of the factors does matter. And with a lot of these counting questions, it's good to look at an example. They give us an example here. The number 6, for example, can be written as itself. Every number has itself as a factor, or 2 times 3, or 3 times 2. So this gives us 6, 2 times 3, 3 times 2, 3 possibilities. So d of the number 6 is equal to 3. Our question here is, what is d of 96? So we're asking how many ways can we write 96 as the product of positive factors there, where the order of the factors matters. So let's start diving into the problem here. We're looking at d of 96. This is a counting question, but it also involves number theory, right? We're talking about factors, we're talking about, right, products of these factors multiplying together. So that's a clue that we might want to start considering stuff like the prime factorization. So for reference here, let's look at 96. And 96 is, of course, 32 times 3, which is 2 to the 5th times 3 in this case. Now, when we have a product of factors, right, each of those factors is made up of the primes, right? These primes are always our building blocks. And so a lot of the times it can be helpful, it can help us understand what's going on if we look at prime factorizations and maybe look at results involving prime factorizations. So the way to motivate what we're going to do a little bit, there's lots of different ways to do this problem, but the way I like thinking about this is focusing on the 2 to the 5th first. Right? We're looking at products of the factors, so all of these factors are made up of 2's and 5's, or sorry, 2's and 3's, right? We have 5 2's and then 1 3. Since we only have 1 3, let's kind of deal with that last. So in other words, I want to focus on our 2 to the 5th. I want to focus in a sense on the 32 a little bit to start. And so we're not going to kind of necessarily have a full formula or recursive formula or stuff here, but I want to start by kind of answering the question, what is d of 32 in the first place there? So here we kind of have just our 5 2's that we're kind of building with and working to kind of come up with our final number in this case there. Right? So 2 times 2 times 2 times 2 times 2 is, of course, our 32 in this scenario. Now, kind of right off the bat, that gives us one way to kind of do this, right? We could group all of the 2's separately, right? So we could have 5 groups of 2 in this case there. And there's only one way to do that in this scenario, right? We could have these 5 different groups of stuff there. And so, right, we could have just a 1 in this case. There's one outcome here where we have kind of 5 groups of numbers in this scenario. Now, what happens if we have 4 groups? So for example here, right, we could kind of group 2 2's together, right? We could have 2 2's, right, and then some other groups of sets of things kind of there. Now, there's different ways to count this, right? One way to do it is kind of think of these blobs here, right? I have 4 blobs, 3 of them are kind of single blobs and 1 double blob. How many ways are there to arrange those things? There are, of course, 4 ways of doing that. So that's if we have 4 groups in this case. We could also think about this as a kind of version of stars and bars. We have 5 twos. These 5 twos need to go in 4 groups, so 4 boxes, but every box has to have at least 1 2. So we could also think about this as a stars and bars scenario where we're kind of putting stuff there and kind of going through it, and we would have then in that case, well, we need 1 2 in each box, so we have 1 2 left over in any of the 4 boxes. We of course get the same answer of 4 here. Right, our second case, right, let's maybe do one more of these before we kind of just start saying there's a pattern and we could hammer them all out. All right, what happens if we have 3 groups in this scenario there? Right, so we do have to be a little bit careful with some stuff if we're thinking about the blobs and things like that there, right? Because you might see, okay, we have a 2 blob, a 1 blob, a 2 blob. There's kind of some ways to do that. But wait a second, we could also have like 2 1 size blobs, right? And then a real big blob of size 3, right? So we have to be a little bit more careful if we're doing the kind of sizes of stuff there. But notice we can still do the kind of stars and bars stuff here, right? Because we have, now we want 3 groups, so we have 2 bars in this case. We know that we have 1 2 in each, right? Because we have to have at least a factor that is bigger than 1 in this case. And so we kind of have 2 stars in this case that are left over. And we have the 2 bars there. So there's 4 choose 2 or 6 outcomes here. Right? You could do this with 2 cases like I just did. 3 plus 3 is also 6. But I think it's nicer to think about these in terms of stars and bars. And we can continue this then with 2 groups. You can also do stars and bars there. And you will get 4 outcomes again. And if we have 1 group, we have, of course, 1 outcome again there as well. So this was just the scenario where we were kind of looking at our D of 32 in this case. Now, this doesn't necessarily relate very nicely to D of 96 because, right, the 3 is a little bit more complicated. But I still think having these outcomes listed and thinking of it in this same way, with these numbers done already as part of D of 32, is really going to help us out in understanding what's kind of happening there. So let's look again at the 5 groups case. In fact, we've just already drawn the outcome that we have there. Right? We have 2 times 2 times 2 times 2 times 2. That is our 32. That was the one way to write 32 with kind of 5 things there. Now, what about our number 3? What could happen with our number 3 in this case? Well, first of all, 3 could go with one of our numbers, right? So the 3 could go with one of our numbers here. And so there are kind of 5 ways we could merge the 3 and the 2. So we could have 6 times 2 times 2 times 2, right? 6 times, right, blah, 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 there. So that's definitely 5 extra outcomes that we could have. So when I start writing this out, I'm not going to write out the 5 groups again and stuff. But this is again the same strategy as before. With the 1 from before, so let me actually kind of highlight this actual 1 there. So this 5 groups, 1 outcome from the D of 32 stays. and then we need to multiply this by some extra outcomes here. So we multiply this by, there are actually 5 of these outcomes where we add the 3 to one of the previous 5 groups there. Now, that's not the only thing that can happen. So if we have our, let's look at our 2 times 2 times 2 times 2 times 2 again here. The other thing that can happen, notice that we could have an extra group added, right? We could have a space at the beginning, or in between these two 2's, or in between, at the end, right? We have these 6 places, right? We could put the 3 at the front, between the first and the second 2, etc. So we have these 6 spots that we could place the 3 into in between the 2's there. So this is an outcome like 2 times 3 times 2 times 2 times 2 times 2. Or 2 times 2 times 2 times 2 times 3 times 2, right? We have these 6 places there that this 3 could be put in between our 2's in that case. So we have 5 plus 6 outcomes, 11 outcomes there. Now, you may somewhat kind of say, well, who cares, right? This kind of is going to be messier as we have more groups and stuff like that there. But it's actually not, because these things don't actually need to be 2's. So for example, if we look at one of these 4 group case, so for example, 32 is 2 times 2 times 4 times 2, we can actually modify everything we did just by kind of grouping those things together the same way as we did before. So even though we have kind of a different kind of outcome there, so whoops, let me kind of fix my diagram here. Right, so we merge these two 2's together there. Then our argument and our strategy is actually still the same there. So we still have, okay, if we have 4 groups, right, we know that there are 4 outcomes from before in total. So for these 4 outcomes, we have 4 outcomes here. But then each of these outcomes can be kind of merged or kind of messed with and manipulated to give new outcomes now that the 3 is being added here. So we have our 4 outcomes, but there are now, because there were 4 groups, there are 4 ways to add a 3 to one of the groups, or we could add a 3 in between 2 of the groups in that case there. So we always have these 2 cases where either we add a 3 to one of the existing groups, or add a 3 in between the groups there. So let's see if we can kind of follow this logic for all of them. I'll go back and highlight this stuff at the end, but we have the 6 outcomes with 3 groups. The 3 can either be merged with one of those groups or put in between the groups. We have 4 outcomes with 2 groups, and the 3 can either be merged with one of the 2 groups or in between the sets of 2 groups. And finally, we have 1 outcome with 1 group, and again, it can either be merged with that group or put in between, or in this case, really ahead or behind that single element there. So it's not like we're actually multiplying d of 32 by something, or we have a recursive formula for d of 32, but we're expanding on the logic we did with d of 32 there, and now thinking about adding the 3 in this case. And because we have a single 3, right, there's that one prime number there, everything works out pretty nicely in this case. So if we calculate this, then we have 1 times 11, so that's just 11. We have 4 times 9, so that is 36. We have 6 times 7, so that is 42. We have 4 times 5, so 20, and 1 times 3, so 3. And if you add everything up, you will get 112, so that is answer choice A, right? So always at the end, we have to hold our breath a little bit, make sure we got one of the answer choices, and we did. We got answer choice A here, our answer of 112. So really just thinking carefully and working through piece by piece got us to the answer there. Focusing on, okay, 96 has a bunch of 2's and a 3. Let's try to use that to our advantage in terms of the prime factorization. Thank you guys for watching this video. I recommend everybody who enjoyed this, right, check out ZIML for more practice. We have a full archive of 10 and 12 AMC exams there. You can access either on the web, ziml.areteem.org, or with our mobile app. There's timed exams, you can do real scoring, so it's a good way to do like a preview, right? Challenge yourself, do it in the set amount of time, see what score you would have got on that exam. We have other mock exams there and a lot of great other resources like our daily magic spells or monthly contests for additional problem solving and other practice there too. So thank you guys for watching. I will see everyone at a later time then too. Goodbye.